Before we begin Unit 23, here is the answer to the Unit 22 question. The best answer is choice D.
Whether we like it or not, our physical ability does have a significant impact on our lives, and the United Nations recognizes each and every individual's health and mental well-being as the key to reaching our full potential as a species. Kinesiology is the study of the biomechanical and physiological mechanisms of movement and is often addressed in science and physical education courses, but is only one specific component of a well-rounded education in fitness. The role that physical education instructors must play is significant. However, regardless of your subject discipline, the grade level you teach, or whoever you are for that matter, physical performance to some degree has to be a factor in your life and worthy of consideration as a component in your educational efforts. Unit 23. Air it out.
Similar to fish in a bowl of water, we live in a very thin blanket of air that surrounds the Earth.
Since its density increases as it nears the ground, the majority of our air is located in the troposphere, or lowest level of the atmosphere.
You can think of it as the air molecules being compressed by gravity the closer they get to the Earth's surface.
The layer above the troposphere is called the stratosphere.
Although organisms do not spend their lives in the stratosphere, this region is very important to life as it contains the ozone layer.
Ozone is a molecule that filters out the sun's ultraviolet radiation and allows life to flourish in the troposphere.
It's important to remember that the atmosphere consists of approximately 78% nitrogen, 21% oxygen, and a 1% mixture of many other gases.
Even though they may only constitute a minor percentage of the atmosphere, some of these trace gases, like ozone, play extremely important roles in our environment, and others, such as sulfur dioxide, may cause serious consequences to our health and well-being.
We, like the majority of living things, need to breathe air. In the most basic sense, we need to provide our bodies with the oxygen our cells need to function properly.
As air enters our nose and mouth, it travels down the trachea or windpipe to the lungs.
In the lungs, there are a series of bronchial tubes that end in alveolar sacs, where oxygen is exchanged for carbon dioxide at the cellular level.
Remember that air is only 21% oxygen, so when we breathe, we are also taking in air particles that are not oxygen.
What if something is mixed in with the air that's not supposed to be there?
That can be dangerous, and we call the unwanted substances air pollution.
Air pollution can be thought of as airborne contaminants in high enough concentration that they may pose a threat to life as well as the non-living environment.
Unwanted substances that are put into the air, such as car exhaust, emissions from factories, or dust from fields, are referred to as primary pollutants.
However, the atmosphere is similar to a gigantic chemistry laboratory, with the sun acting as a perpetual energy source.
Once the primary pollutants are in the air, they can react with each other and form new substances called secondary pollutants.
For future reference, air pollution sources such as cars, trains, and planes are called mobile sources, whereas those that do not move, such as factories and power plants, are known as stationary sources.
There are obviously a large array of air pollutants, however some have gained more attention than others.
Let's now take a closer look at the major ambient or outdoor air pollutant categories known as carbon oxides, nitrogen oxides, sulfur oxides, particulates, ozone, and volatile organic compounds.
When a fossil fuel such as methane burns completely, the product should be carbon dioxide and water. However, the key word is completely.
Oftentimes, these fuels do not react to completion, and carbon monoxide, a potentially dangerous gas, is produced.
Carbon monoxide, CO, is a specific type of non-toxic gas referred to as an asphyxiant. As such, it interferes with the lungs' ability to process oxygen by combining with hemoglobin in red blood cells.
Carbon monoxide can cause headaches, nausea, confusion, coma, and death by depriving a person of the oxygen that the body needs.
Since carbon dioxide, CO2, is a natural product of respiration, you may not think of it as a pollutant. However, human activities are producing massive amounts of this substance.
The legitimate scientific community is in agreement that increasing levels of carbon dioxide are contributing to human-induced climate change.
Collectively, carbon monoxide and carbon dioxide are referred to as carbon oxides.
The burning of fossil fuels from both stationary and mobile sources produces the primary pollutants nitrogen monoxide, NO, and nitrogen dioxide, NO2, collectively called oxides of nitrogen.
These substances react with water in the atmosphere to form the secondary pollutant, nitric acid, HNO3, that contributes to acid rain.
They also produce smog, a combination of smoke and fog.
Specifically, nitrogen oxides produce a reddish-brown photochemical smog referred to as the brown cloud.
We often remember glancing out of a high-rise office window overlooking downtown Phoenix, Arizona, shortly after being married, and seeing what can only be described as a brown cloud, so we can say from experience that the term does seem to fit.
Nitrogen oxides can irritate the eyes, nose, and throat, and aggravate existing conditions, such as asthma and bronchitis.
Coal-burning power plants are a major emitter of sulfur dioxide, SO2.
Sulfur dioxide reacts with water vapor in the atmosphere to produce sulfuric acid, H2SO4.
Sulfur dioxide and its secondary pollutants cause damage to crops, trees, soil, and aquatic life.
These substances corrode metals and damage outdoor materials such as paint, leather, and stone statues.
In cities, the sulfate particles resulting from sulfur dioxide emissions cause severe reductions in visibility and contribute to gray air smog.
Suspended particulate matter, commonly called particulates or dust, may not sound so dangerous. However, depending on toxicity level and size, can cause serious harm or even death.
If you inhale a poison, you introduce that substance directly into your bloodstream.
Obviously, therefore, any toxic particulate in the air is dangerous and can cause a whole host of illnesses, from reproductive problems to cancer.
Another concern that scientists have with regard to particles is their size. Actually, the bigger the better, as we have effective defenses against large particles.
If you inhale chalk dust, a relatively large particulate, you usually cough many of the particles right back out. The majority of the others are trapped by mucus, the lining of the lungs, and other defense mechanisms.
Unfortunately, when particles are so small that they bypass these defenses, they can directly interfere with the oxygen exchange occurring with red blood cells in our lungs, resulting in serious health issues.
You may hear scientists refer to good ozone and bad ozone.
Good ozone, O3, is a molecule that forms a layer in our stratosphere that protects the Earth from harmful ultraviolet radiation.
Bad ozone is the same molecule, but it's located right here in the troposphere. If you've ever spent a lot of time around a copy machine, you know how ozone smells.
Ozone can cause coughing and breathing problems and can aggravate existing conditions such as lung and heart disease.
Our students often suggested that we just pipe the bad ozone up into the stratosphere.
We wish we could, but unfortunately there is no economically feasible method of transporting ozone from the troposphere up into the stratosphere.
No discussion of air pollutants would be complete without mentioning volatile organic compounds, or VOCs.
VOCs are gases in the atmosphere that have evaporated from liquid or solid sources.
Some of these volatile organic compounds can be very toxic in small quantities.
Examples of highly toxic VOCs include benzene, toluene, and methylene chloride.
When you open a can of paint thinner, you smell volatile organic compounds.
The hazards associated with VOCs can be compared to those posed by any toxic chemical.
As mentioned earlier, primary pollutants such as nitrogen oxides and sulfur oxides can react with water in the air to form the secondary pollutants, nitric and sulfuric acid.
When these acids rain down to Earth, they degrade the soil and aquatic ecosystems by unnaturally lowering the pH or increasing acidity values.
This process is known as acid deposition or acid rain.
One of the biggest issues associated with acid deposition, and all outdoor air pollution for that matter, is that it's not a localized problem.
For example, a town in the United States can have a factory producing sulfur dioxide and may never experience any of the negative effects of this pollutant, while several hundred miles away, a lake in Canada may be completely destroyed due to the resultant acid rain.
The only real solution to the acid rain problem is to reduce our dependence on fossil fuels, burn less effective low-sulfur coal, physically or chemically control emissions at the source, or tax emissions in order to discourage contributing practices.
Once affected, contaminated areas can be treated with alkaline chemicals, such as lime or phosphate fertilizer, to neutralize the acid deposition, but this is never a permanent solution.
The pollutants discussed so far are often associated with outdoor or ambient air. Obviously, there are many factors that determine the effects that these air pollutants can have.
Those that tend to reduce the negative effects of these pollutants are gravity, rain, wind, and biochemical reactions.
Those that tend to make matters worse include tall buildings and hills that inhibit air circulation, high temperatures, and natural VOC emissions by vegetation.
Human beings can reduce air pollution at the source by using a variety of technologies designed to remove contaminants.
We'll discuss these strategies in more depth in a following unit. However, there are two basic kinds of removal systems: physical separation techniques for particulates and chemical methods for gases.
Remember as children, our parents would tell us to go outside and get some fresh air? If we knew then what we know now, we may have responded, how?
Here's your question for Unit 23.
Which of the following is not a major ambient or outdoor air pollutant category?
Choice A, sulfur oxides.
Choice B, particulates.
Choice C, water vapor.
Or choice D, volatile organic compounds.
The answer and explanation are provided at the beginning of Unit 24.